This question gives us the vertex of a parabola at -3, 2, and the focus at -3, -1, and it's asking a bunch of questions. The axis of symmetry, the directrix, the equation, the graph, find a point on the graph, and then show that the point is equidistant from the focus and the directrix. So let's look at those points. We have -3, 2 and -3, -1. And let's identify what we have here. So -3, 2 is the vertex. So we'll label that with a V. And -3, -1 is the focus. We'll label that with an F. And we know that the parabola starts at the vertex and encompasses the focus. So it's going to be an opening downwards parabola. So what do we know about an opening downwards parabola? An opening downwards parabola like this is of the form x squared equals 4py, where p is negative. Okay, except of course the vertex is not at the origin, the vertex is somewhere else. So if I shift the vertex, it becomes x minus h squared equals 4p times y minus k, where the vertex is hk. In my problem here, the vertex is -3, 2. So what will that give me? X minus h. X minus -3 becomes x plus 3 squared is 4p times y minus k times y minus 2. So that's the shape of our graph, the type of equation we're working with. Now what is p? Remember, p is the directed distance from the vertex. The vertex is here. The focus is here. What is that distance? And again, p is negative if it's opening downwards. So let's go back and look at our picture to see what we have. From the vertex to the focus, count 1, 2, 3. It looks like p is 3 or p is -3. So knowing that, where does that put me? So that directed distance from the vertex to the focus, p is -3. So that my equation becomes x plus 3 squared equals 4 times -3 times y minus 2, x plus 3 squared equals -12 times y minus 2. So we have our equation of the parabola. We have not determined the axis of symmetry, but we'll get that here shortly. So let's go back here. We believe that the following is our equation of the parabola. X plus 3 squared equals -12 times y minus 2. And the p-value we had was -3. How about axis of symmetry? What's cutting this in half? It's parallel to the y-axis, so it's this line right here. So what is my axis of symmetry? That is the vertical line going through the vertex and the focus. That, of course, is x equals -3. That's our axis of symmetry that we can see here. How about our directrix? Remember, the parabola is a set of points equidistant from the focus and the directrix. So the distance here is 1, 2, 3 to the focus. I've got to go 1, 2, 3 here to the directrix. So the directrix is this horizontal line here. What would that equation be? It goes through 5. That equation is y equals 5. So there's our directrix at y equals 5. There's our axis of symmetry at x equals -3. We have our graph. I want to find a point on the graph. And the way we do this is we have 1, 2, 3 is our p-value. Let's go out 6. 1, 2, 3, 4, 5, 6. This is a point on the graph at x is 3, y is -1. Or we could have gone 6 the other way, which would have been -9, -1, but I'll stick with 3, -1. So I found a point on the graph, which is on the lattice rectum, that point 3, -1. You'll notice it is 6 units away from the focus. 1, 2, 3, 4, 5, 6. And how far is it from the directrix? 1, 2, 3, 4, 5, 6. So not a whole lot for us to do there, other than to write that 3, -1 is the point on the graph. Directrix is y equals 5. Focus is -3, -1. So what can we say? This is the information. Let's see, from 3, -1 distance. From 3, -1 to y equals 5 is what? Well, again, you can just think about it. 1, 2, 3, -1 to y equals 5. It's 6, right? 5 this way, 1 more. Distance is 6. And distance from the focus is not, the focus is -3, -1, okay. So what is the distance from 3, -1 to the focus to -3, -1? Again, I hope that's pretty much obvious. Remember that parabola is a set of points equidistant from the focus and the directrix, and again, that distance equals 6.